All right, it is live. Looking at the sun on 193 angstroms. I think we got the screen formatted a little better today. Looking at the sun on 193 angstroms. So we changed out the resolution here to fill up the wide screen. And we see the moon going across the SDO, which brings up the burning question for a lot of people, I'm sure. How does that happen? So I would most definitely send you to the SDO website here. As if you're on the SDO website, you will be able to see where the SDO is located. Just go to Mission, click on Where is SDO, and you get this page. And now you see that figure 8 shaped orbit there. That is why we see what's going on with the SDO. It's moving around the same speed as the moon, which is why it's able to overtake the moon in the way that we see. So let's cut the music. We'll save that for the end. And thanks for tuning in, viewers. I think we got 2 people in the chat, but that's okay because it's pretty early in the morning here. 3:56 Eastern Standard Time here. We're located in Eastern PA. And again, that is why the SDO gets eclipses. I prefer to refer to it as an occultation, but anyway, you can refer to that page if you like. That's why we see the moon going in front of the SDO. So let's look at sunspot 2734. As its magnetic complexity has not really ceased, although the cores they look like they're getting farther away from each other. So that could be an indication that it's shrinking a bit. And let's zoom back out and look at it from the 171 angstroms perspective here, which is a good view to look at magnetic looping. Let's get this thing full screen. There you go. And there's the moon swinging in front of the SDO and then back again as the SDO does one of its figure 8 orbits. This does give the SDO operators some chance to look at the instrumentation, because when you have this moon swinging in front, you get this edge here, and that helps to show distortions in the scopes. So anyway, that's what's going on with that. Let's look at the real-time solar wind. If it loads. Come on, real-time solar wind. There we go. Okay. Let's try to refresh that. There we go. All right, so we do see a couple little connections here on the phi angle, which look like coronal hole connections. Right there's one. And a little sputter right here. And that's about it as far as coronal hole magnetic connections, which is a good thing, as those are an increase earthquake risk factor. So we see the solar wind density, 4.7 protons per cubic centimeter there, and solar wind speed still declining down to 366 kilometers per second. What's the next tab? We got solar ham open. They've always got an analysis of the active regions right on their homepage. You just click on the region. And so we still got beta class sunspot there, which means we've got two different fields. And the umbra on this one here, you can see it actually grew a little bit bigger since yesterday. Moving on to spaceweathernews.com. Make sure that's refreshed. By the way, we highly recommend Brave Browser, a browser designed to not track you. Pretty much the opposite of most other browsers. There we go. So see some X-ray flaring there. Some couple little tiny B-class flare occurred. Undoubtedly coming out of that sunspot. So we'll be keeping an eye on that to see if there's any more activity coming out of it. As those fields move farther apart, their reconnections will become more violent. Now we see the magnetometer is still, yeah. So regular viewers, where has the GOES 14 gone? Anyway, no data from that. Not sure what's going on with the GOES 14 and 15. If anybody's heard from NASA, please let us know. The KP index down to 1. Electron flux is smoothing out, it looks like, which is what you would expect. And the surface, the charging hazards are finally diminishing there. And the F2 layer is pretty highly charged once again. So we see this highly charged region right here. That's the highest charge we've seen around this time of day for a while. So we'll attempt to look at the low pressure zones around South America there. Anyway, let's move on here to the total electron content while we're looking at the worldwide view. Make sure that's refreshed too. I actually went running yesterday. I did about a 2.5 miler straight up a mountain and straight back down the mountain. And I had GPS errors. My GPS actually missed the first like quarter or half mile of my run. And we do see some significant electron content there over North America, as we did yesterday. So that's your total electron content forecast. Let's look at the geospace magnetosphere movies here. Here's your velocity. Fairly low velocity solar wind coming in there. Nothing too unexpected. We do see a low velocity zone associated with the South Pole, actually. All right, and here's the density. We see some variations in the solar wind also there. Density a bit lower around the planet than it was yesterday. Keep in mind, the white part is the low density, and the blue part is the high density. Lastly, here's the pressure, which is fairly low as expected, with the solar wind density and speed as low as they are. Next, we'll look at the geospace ground perturbations before we move on to volcanoes and earthquakes. Steady as she pressures. Here's the geospace perturbations from the poles. Thank you for joining us. 4 viewers rather. Not a lot going on. I would just note that the South Pole is headed toward the Indian Ocean. Here's a view from the globe. Just like to note that we've got a North Pole up here. We've got a North Pole up here. And the South Pole is way over here. So you do see that all reflected in this. Let's move on to the Gong 2. Make sure we got the latest here. In fact, let's actually look at this. Let's look at the line of sight field plot here for a minute, so we can show you how the sunspots affect the B field, which is this blue portion. This is the B field, and these are the Z fields up here, the polar fields. So we'll just let this play so you can see how the sunspot pulls the fields back. Shrink that down a little bit. This data 1 hour and 52 minutes old. And you can see some effects based on that sunspot's magnetism. That's what's causing those undulations in the B field. And let's look at the one we normally look at, the top view ecliptic plane field plot. I would note this area right here. It's got some magnetic complexity. And as we've said many times in the past, keep in mind all that stuff can change with no warning at all. The same way we see sunspots appear with no warning at all. Let's move on to the earthquakes. Make sure that's refreshed. And what do we got? Going back a full 24 hours here, we see a 4.1 in Mexico. Alaska getting hit regularly there. We got one in Honduras. Before we go on, let's draw the watch area here. This is your earthquake watch zone. The magnitude 6 and 7 drought is still on. And despite sunspots and a little higher activity, these areas are still experiencing a drought. So if you're in those areas, please have a plan. Please be a liability. Please be an asset instead of a liability. If you're in those areas, a little flashing graphic for you there. Also, we see one in Indonesia, right in the middle of the warning zone. And no tsunami warning, advisory, watches, or threats. That's a good thing. All right, where were we here? Quite a few quakes. So here's a 5.4 in New Zealand. Oh, a 6.4. Oh, all right. Well, there's a partial end to your 6 magnitude earthquake drought. I know somebody down there. I'll have to ask her if she felt that quake. I'm not sure what part of New Zealand she's located in, but that's a pretty big one. Let's see here. Nope. All right. Good thing. No tsunamis. All right. Will be interesting to hear how severe that was. It was near the surface. All right, moving on. Also a 5.0, right in the same place practically. Here's a 4.7 in Russia. .0 in Japan. And 5.6 in Papua New Guinea. 4.9 in Japan. So we do see a little uptick. Another 5.0 in Japan. Here's one in Saudi Arabia. Another 5.7 in New Zealand. Let's look at that swarm there. All just east of the plate boundary. There's a location of that. And this is a pain. Let's go to global incident map. I really hate navigating that USGS site, folks. I can't stand it. I can't stand it. I hate it. All right, so let's get back to where we were here. 5.0 in New Zealand just 6 hours ago. .9 in the northern mid-Atlantic ridge. Jeez, I can't keep track. All right, 5.2 in Peru, a 5.0 at depth in Chile, raising the risk for another larger quake at the surface there. 4.4 in Pakistan, and a 4.6 at depth in Indonesia. So sadly, that 6.4 off of the coast of New Zealand is not going to end the 6 and 7 magnitude earthquake watch. Excuse me. All right, what else? We got volcanoes. Whoops. Load the home page. There we go. Here's today's volcanoes. We've got Mount Mayon now on the list, producing a 10,000 foot ash plume. Karangatang back on the list, 9,000 foot ash plume there. Dakono, still a 7,000 foot ash plume there. Popocatépetl has upticked with explosive activity. We showed a little bit yesterday. 24,000 foot ash plume there. Fuego with a 15,000 foot ash plume. Revenador, 16,000 foot ash plume. Sabancaya, unable to detect. Planchon Petaroa still with a 15,000 foot ash plume. So consider that an uptick in volcanoes and earthquakes. By the way, head to smAsho. Head to youtube.com/smAsho and check out our officially endorsed channels, which are, by the way, in a random order. It won't display them all, so click here on channels, and then you'll see the whole list. There's about 14 of them. Next, let's look at zooniverse.org. and talk about the Galaxy Zoo, one of the largest citizen science projects in the world. We need human beings to visually analyze some galaxies. So since computers can't do it, and this one is very freaky, very strange, let's classify it. In fact, let's download it too. All right, save that one for posterity because that's a weird looking, blue shifty looking galaxy that's shaped like a slug. So anyway, we're going to say features or disk. Is it an edge-on disk? Not really. Is there a bar? We're going to say a weak bar, just to attract additional attention. Is there any sign of a spiral arm pattern? Well, certainly not. Is there a bulge? We're going to say small bulge. Is it merging or disturbed? We're going to say minor disturbance because it looks a little unsymmetrical there, a little asymmetrical. And we're going to say irregular. And we'll just say something else. I'm not sure what's going on there, but it's a little odd looking. So there's a galaxy classified. Here's the next one on the list. Go classify a galaxy. Have fun. Get published, etc. Set up a login. Zooniverse.org. Galaxy Zoo Project. And let's just take a look at the water vapor map over the US here. Set up a top level animation for you. And we'll also look at the AccuWeather US Doppler map. That wasn't what we wanted. All right, let's put this back over here. By the way, if you've got a Minds.com account, please come visit us at minds.com/smAsho. We occasionally put up other content there. Let's go back to the US Doppler radar. There you go. See some heavy snow bands across central US there. South Dakota, Nebraska, Iowa, and Missouri. Some heavy rains around the Great Salt Lake and scattered snow and rain showers all across the west. Here's what's going on in the water vapor. Get rid of my earthquake warning zones. And can we zoom in? Yeah, we can. All right, there we go. So you can see essentially what's going on here is this dry mass of air. That's not big enough. This dry mass of air down here is kind of acting like a barrier, forcing this moisture up like this, where it's converging with this cold jet stream flow. And that is causing this low here to kind of back up. So as this slowly makes its way to the east, that's what's going on. So yeah. By the way, if you want to see what's going on in the cloud layer, when it's dark, check out the band 7 shortwave radiation map. And you'll be able to see what's going on with the clouds even when it's dark. So we look at the water vapor map because The water vapor map shows us water vapor that isn't condensed onto clouds, as well as water vapor that is. This one tries to show you the clouds in total darkness. So there's what's going on in the cloud layer, if you're interested in that. Now we've got some articles we want to cover here. And I have them on my phone, so I'm going to have to type them in. All right, so got a phys.org article about Jupiter and Saturn's unexpected magnetic fields. So a new surprise is from Jupiter and Saturn. The detailed magnetic and gravity data have been invaluable, but also confounding. So this has to do with the magnetic fields. Please don't ban us, YouTube. We're going to keep the volume off for this, but check out this amazing animation, which actually shows you the location of Jupiter's magnetic fields. And I'll tell you what, Jupiter looks like it's having a magnetic excursion similar to the Earth's. Look at that. There's Jupiter's magnetic fields. You can see it looks like it has 3 north poles. And yeah, it's got poles all over the place. So that's a good explanation of how Jupiter's able to do what it does. Keep in mind, Jupiter's dynamo also involves its moons. Some of the moons have magnetic fields, so it's a complicated thing. And let's move on to another article also on phys.org. Actually, you know what? Let's not even look at that. There's something else I wanted to show you here real quick, because I saw a paper that I was not aware of. I'm going to look up the Greenland ice mass budget. All right, now I know some of this stuff came down, but there is still a PDF document that you can download. Okay. All right, I think it's available on this site. I can't remember. Okay, so this was written right at the end of 2018. Let me see if he includes the PDF here. That's not actually the graph we're looking for. Just bear with us 1 minute here. We will find the correct information. By the way, we will leave links to this and all the other articles. I'm sure a lot of folks will be very interested in looking at Jupiter's magnetic field lines. Greenland ice sheet surface mass budget. Not sure if I searched for the wrong thing there. I know there's been issues with the Danish Meteorological Institute. Let me just see what this one shows. I downloaded a PDF in Greenland speak, which wasn't very helpful. In any case, I'll leave links to the PDF document regardless. But what they're showing is a really late spring and a really early winter and a really low amount of ice melt in the months of June, July, and August. Oh, and record high albedos. So I will put a link to the PDF that I downloaded. I'm not exactly sure why I can't find it on the computer, but I can on the phone. Figure that one out. Let me see. Polar Portal. Let me see if I can find it this way. Okay, they got it spelled real weird, folks. All right, I think this is the one. There we go. Hopefully it'll download the English version. See what happens. There we go. All right, good. All right, so you can just leave links to this. Now, here's what happened in 2018. Check it out. Wild spikes in the ice mass budget. Look at the mass gain statistics over here. Look at that. Look at the end of the graph. It goes right off of the scale. Also, look at the early winter. Ice begins to reform in mid-May, and it barely tries to melt in June, July, and August. Look how high above the average it is. So, yeah, Greenland not really melting. And maybe interested to note that the albedo was record high in May, June, and the beginning of August. So the albedo effect is sunlight being reflected back into space, because things like ocean absorb a lot of heat, and things like ice reflect a lot of heat. Here's the Arctic sea ice extent, which is basically irrelevant, because if you don't know the volume, you don't know how much ice is there. But yeah, so we'll leave links to that also after we're done with the stream. Just before we do that, just one other little thing here. Just look at Arctic sea ice thickness and volume. You could note all of these areas in here where it's 4.5 meters plus in thickness. I mean, you got 4.5 meter thick ice here and all around here. Little pockets of, that's 4.5 meter thick ice, folks. So it's not melting up there. And if you look at this graph, the volume right here, it's right in the middle of the range. So anyway, just figured I'd throw that in there, because it's hard to read science articles without hearing something about global warming. Let's look at the last 12 hours. On the SDO. That wasn't what I wanted. 6th. There's the last 12 hours. There's a great view of the moon swinging past the SDO twice. Let's look at it in a different wavelength. I don't know if you've noticed I've gotten a little better at using this site. There is an interesting filament up there in the northeast. It's being eclipsed. Zoom in on that. A bit of a towering filament. All right, well, we got to get out of here, folks. So thanks for tuning in. We'll be doing it all again tomorrow. Thanks, subscribers, donors. Please don't forget to press like if you enjoy the content. And remember, On your way explaining why this happens, don't drink. And if you drink, explain why this happens. Just don't drive. Please don't drive.